2021 grade 12 math trial examination paper, right? So we have this first question here, 1.1.1, which says 2x multiplied by 3 minus x is equals to 0. So for this equation to be equals to 0, right, it's either 2x is equals to 0 or 3 minus x is equals to 0. If one between the two is equals to 0, then their product will be 0, right? Or if all of them are equals to 0. So how do we potentially solve this? So we say that we need 2x to be equals to 0, or we need 3 minus x to be equals to 0, right? So if 2x is indeed equals to 0, then x will be equals to 0 divided by 2, which is just 0, right? And then indeed, if you substitute it here, if you substitute 0, that equation will satisfy what it's supposed to satisfy, right? Which is 0. On the other side, we're gonna get minus x being equals to minus 3. So x is equals to 3, right? And then that also satisfies our equation. If x is equals to 3, then we have 3 minus 3, which is 0. And then our equation is satisfied. So let's move forward and do 1.1.2. So 1.1.2, we have 5x squared minus 4x is equals to 2. And then let's solve for x and round off to 2 decimal places. Soon as we see that we have to round off to 2 decimal places, we know fully well that we're supposed to use the quadratic formula, right? So let's rearrange our equation and write it in the standard format. So we're going to have 5x squared minus 4x minus 2 is equals to 0, right? Now we have our equation in the standard format. We know fully well that 5 will be A, and then minus 4 will be B, and then minus 2 will be C, right? And the general formula for a quadratic equation is given as x is equals to minus b plus or minus, we have b squared minus 4ac divided by 2a. So now it's just a matter of substituting into this equation and we get our values of x. So x will be equals to minus, we said b is minus 4, so minus 4 plus or minus b squared minus 4 squared minus 4ac. A is 5 and then c is minus 2, and then we divide in everything by 2a. A is 5, like we've already said, so we just have that. So we're gonna get x equals to, so when I get to this point, I don't want to put this individual term in the calculator and then put this term in the calculator and then put this in the calculator and keep going down. No, I don't want to do that. I put this in the calculator as it is, just to avoid the mistakes I can possibly make, right? So you put it in the calculator, and then for the first time you put plus here, right? And then for the second time you put minus, because it's supposed to get 2 values, right? So if you do that, your x will be equals to minus 0.35, or your x will be equals to 1.15, right? Let's do 1.1.3. 1.1.3 says we have 7 plus 3x plus 2x being equals to 0, right? We're still solving for x. So we have that square root, so we have to square both sides, right? But then if we square both sides while we still have this 2x here, then so many issues are gonna arise. So the first step, let's take 2x to the other side. So we're gonna have 7 plus 3x being equals to minus 2x. Now we can square both sides in peace, right? And not so many issues will arise. So we're gonna have 7 plus 3x is equals to 4x squared, like you would expect. And then if we rearrange this, we get 4x squared minus 7 minus 3x. Actually, let's start by minus 3x so that it can be standard format, right? Minus 3x minus 7 is equals to 0. So here we are, right? If I have an equation like this and then a is not 1, I usually resort to using the quadratic formula, right? Because for the most part, it's just too complicated when you don't have 1 there as the coefficient of x squared, right? But then if you can factorize it, then obviously you can go with that, but I really recommend the quadratic formula because you can never really go wrong with the quadratic formula. So if you factorize this, you get x plus 1 4x minus 7 is equals to 0. I really don't recommend factorizing when you don't have a coefficient of 1. It's a bad idea. You're gonna lose marks unnecessarily. Just use the quadratic formula. Yeah, like even if it seems easy to factorize it, and then after that use the quadratic formula and see if it works out. The quadratic formula is just the way to go. So now we can say x plus 1 is equals to 0, or 4x minus 7 is equals to 0. So x can be minus 1, or x can be 7 divided by 4, right? So we have minus 1 and 7 divided by 4. So I want you to realize something. We had this equation initially, right? And then in attempt to solving the problem, we squared the two sides, right? When you square the two sides, you allow solutions that are not necessarily true to be true. Let's say, for instance, you have x is equals to 2, right? And then instead of solving x is equals to 2, you say, let me solve x squared is equals to 4, because they are essentially the same thing. If you decide to solve x squared is equals to 4, then 2 will be a solution. But not only will 2 be a solution, even minus 2 will be a solution, right? The minus 2 will satisfy what you have changed your expression to, but then it won't satisfy what you were initially trying to solve, right? So the same thing happens here. We have squared the two sides. We have introduced solutions that are not necessarily true. So it's now our job to go back to the equation and see which one between the two solutions doesn't necessarily satisfy what we're trying to satisfy, right? So again, let's have 7 plus 3. In place of x, let me put minus 1. So this will just be minus 3, right? And then 2x when x is minus 1, so this will be minus 2 being equals to 0. So you can see here we have 4 minus 2, square root of 4 minus 2, so this will be 2 minus 2, so this is equals to 0. So it seems like this one works. Let's check the other solution which we have, and then so we have square root of 7 plus 3 multiplied by 7 divided by 4 plus 2x is equals to 0. Already you can see that this will not be equals to 0, because here we're gonna get 7 plus 7 14 21 divided by 4 plus 14 divided by 4 is equals to 0, and this is clearly not equals to 0, right? So this solution here, it falls apart, so it's not applicable, right? And then there's actually a mark for rejecting that other solution. And then let's move forward. Let's do 1.1.4. So 1.1.4, it is saying to us we have 3 to the power x plus 2 plus 3 to the 2 minus x being equals to 82. So when I see problems like this, the first thing I want to do, I want to change everything and give it a base of 3. And then if I give everything a base of 3, then I can let 3 to the power of something be k and factorize with ease, right? But then there's no way you can put 82 to the base of 3 and then have a whole number as the power of the 3, right? So yeah, now it becomes a bit complicated, but let's see what we can do. So 3 to the power x plus 2 is the same as 3x multiplied by 3 to the power of 2, right? And then here we have 3 to the power of 2 multiplied by 3 to the minus x being equals to 82. So this is the same as 9 multiplied by 3 to the x plus 9 divided by 3 to the power x. Why are we saying divided by 3 to the power x? Because a to the minus 1 is equals to 1 divided by a. So 3 to the minus x will be equals to 1 divided by 3 to the x. So we can bring 82 to the other side. So we're going to have minus 82 being equals to 0, right? So now we have this denominator of 3x on the middle term. So let's multiply throughout by 3 to the x, right? So that we can sort of have a linear equation. So if we do that, we're going to have 9. We have 9 multiplied by, so we have 3 to the power of x, which is here, multiplied by 3 to the power of x. We are multiplying out with, right? So if we do that, we're going to get 3 to the 2x, because same basis, you add the exponents, plus 9, because 3x multiplied by 1 divided by 3x will just be 1. So here we have minus 82 multiplied by 3x being equals to 0 essentially. Yeah, but let's see if we can. So now we can, try factorize this. But then it's very difficult when you have this kind of things, right? It's very difficult to factorize it like that. So what I like to do, I let let 3 to the x be equals to k, right? So if I'm dealing with k, it will be more easy to factorize compared to when I'm dealing with 3 to the 2x. So we're gonna have 9 multiplied by k squared plus 9 minus 82k being equals to 0. So let's rearrange and write this in standard format, right? So we have 9k squared minus 82k plus 9 being equals to 0. So we can factorize this and find k. Obviously, I don't recommend factorizing. Use the quadratic formula so that you can never go wrong, right? So if you insist on factorizing, you're gonna get 9k, and then on the other side we have k, and this is all equals to 0, right? And then with 9k you have minus 1, and then here you have minus 9, and then if you multiply out, you should get the same expression, right? Let's just check real quick and see if it's true. So you have 9k squared minus 81k minus k plus 9. So this is minus 82k. So yeah, we have factorized correctly, but I don't recommend it, as I've been saying. So now we can say that 9k minus 1 is equals to 0, or k minus 9 is equals to 0. So k is equals to 1 divided by 9, and then on the other side we have k being equals to 9. So we know fully well that k is 3 to the x, right? So we have 3 to the x being equals to 1 divided by 9, or 3 to the x being equals to 9. Yeah, so let's see. So here we have 3 to the x. 1 divided by 9, you can write it as 3 to the minus 2. And then here you can write 9 as 3 to the power of 2. So we have x is equals to minus 2, same basis. So we drop in the basis and equating the exponents. And then we drop in the basis and equating the exponents. So here we're going to have x is equals to 2. And then that's how you essentially solve your problem. Let's do 1.2. So for which values of x will the square root of x squared minus 5x plus 4 be real, right? So let me just write that down. So we have the square root of x squared minus 5x plus 4, right? If it's indeed real, then that should be greater or equals to 0. If the question was saying for which values of x will that expression be not real, right, then it will be less than 0, right? But then here it is saying for which values will it be real, so we're saying greater or equals to 0, right? So it should be obvious now how we should move. We're squaring both sides, so we get x squared minus 5x plus 4 being greater or equals to 0, right? So now let's find our CV, critical values, right? So we're going to equate to 0 so that we can find our critical values. So we're going to get x squared minus 5x plus 4 being equals to 0. So we essentially factorizing here. We get x, and then this is equals to 0. So now the question I'm asking myself, which two numbers do I multiply and get 4? But then when I add, I get minus 5. So that is minus 4 and minus 1. So x is equals to 4 or x is equals to 1, right? Now this is where the magic happens, right? So there's two possible solutions to this problem. It's either the answer lies between these two critical values or outside the critical values. Let me show you what I'm talking about. It's either our answer is between 1 and 4 or is outside that domain, right? That is x being less or equals to 1 or x being greater or equals to 4. So one between these two solutions, you have solutions 1 and 2. One between these two solutions needs to be true, right? So if you try out a solution in the first possible solution and then you get the right answer, then that solution is right and the other one is wrong, right? And vice versa is true. So let's pick a number between 1 and 4. If we pick a number between 1 and 4 and we substitute it here in our equation and our equation is satisfied, then our answer lies between 1 and 4. And then if that number that we pick doesn't satisfy our equation, then without testing the other solution, the other solution is automatically true, right? So between 1 and 4, let's pick 2, right? So here we're gonna have 2 squared, which is 4, minus 5x, we're saying x is 2, so that will be minus 10 plus 4. So we have 4 and 4 cancelling out. Now we have square root of minus 10 being greater or equals to 0, right? And we know fully well that that cannot be true. We cannot take a square root of a negative number at this level. So the first solution falls apart. So this is wrong, and then the second solution is the correct one, right? Try out a number that is in this, that satisfies these conditions, and tell me if that equation is not satisfied. Last but not least, let's solve simultaneously for x and y. So we have xy being equals to 12, and then x minus 4 is equals to y, right? So if I make x or y a subject of the formula in this equation, then I'm going to get a fraction, and then I'm going to have to deal with the fraction, which is something I don't really want, right? So I'll just make x or y the subject of the formula in this second equation. So let me make x the subject of the formula. So I'm going to get x is equals to y plus 4. right? So now I can substitute this value into this equation. So we have, in place of x, I'm gonna have y plus 4 multiplied by y being equals to 12, right? So y squared plus 4y minus 12 is equals to 0. So let's factorize. So which two numbers do I multiply? Get minus 12, and when I add them I get 4. That is 6 and minus 2, right? So we have plus 6 and minus 2. So y is equals to minus 6, or y is equals to 2. So now we can find x, right? If y is equals to minus 6, then x will be equals to 12 divided by minus 6, which is minus 2, right? And then if y is equals to 2, then x will be equals to 12 divided by 2, which is equals to 6, right? I'm just substituting into this equation here and finding our value of x. Let's do this trig equation real quick. We get told that the pth term of the first differences of a quadratic sequence is given by tp is equals to 3p minus 2. And then 2.1 says, let's determine between which two consecutive terms of the quadratic sequence the first difference is equal to 1450. So this equation that we have here is not the equation. This equation that we have here is not the equation of the quadratic sequence. It's the equation of the first difference of the quadratic sequence, right? So let's say, for instance, we had a quadratic sequence with terms 1, 4, 9, 16, right? And then let's find the first differences. We're just using this to make an example, right? 4 minus 1 is 3, and then 9 minus 4, that is 5, and then 16 minus 9, that is 7, and then 5 minus 3, that's 2, and then 7 minus 5 is 2, right? So in this question, we are given the equation of this sequence here, the sequence of the first differences. If the question was asking us, in which two terms does 5 lie, right? It lies between T3 and T2, right? And then in between which two terms does 7 lie? It lies between T4 and T3. But here we have an equation for the first differences instead. We have Tp is equals to 3p minus 2, right? And then we know that that term that we're looking for is 1450, which is equals to 3p minus 2. So if we solve for p, then we're gonna know which position that term lies, right? Clearly here, if the term is in position 2, then it is between term 3 and term 2. And then if it's in position 3, then it's between the fourth term and the third term, just like that. So let's go ahead and solve for p. So we're gonna have 3p being equals to 1448. We divide both sides by 3, we get p is equals to 484, right? So now we know that this term 1450, it lies between the 485th term and the 484th term. So this term lies between 485 and 484th term, right? Because term number 2 lies between 3 and 2, term number 3 lies between 4 and 3. So term 484 will lie between 485 and 484, right? Now let's do 2.2. For 2.2, they tell us that the 40th term of this quadratic sequence is 2219, and then they give us an equation. Tn is equals to an squared plus bn plus c, and then they want us to determine the value of c. I want you to realize something. If we have the equation of the first differences, then we can find B and A, right? And then if we have B and A, we can substitute T40 to determine C. Let me show you what I'm talking about. Because we know fully well that TP is equals to 3P minus 2. So the first term, in place of P, we put 1, right? So we have 3 minus 2, which is 1. And then the second term, we have 3 multiplied by 2, which is 6, minus 2, and then that is 4. And then 3 multiplied by 3, that is 9, minus 2, that is 7, right? And then this is the first difference. Now let's find the second and common difference, right? 4 minus 1, that is 3, 7 minus 4, that is 3. And then we know fully well that 2a is equals to the common difference. So we're going to have 2a is equals to 3. So a is equals to 3 divided by 2. Right? Apart from that, we know that 3a plus b is equals to first term of first difference. Right? So 3a plus b will be equals to 1, right? So we have b being equals to 1 minus 3a, but we know what a is, right? A is 3 divided by 2. So this will be equals to 1 minus 9 divided by 2, which will be equals to minus 7 divided by 2. Now we have the value of b, right? We can substitute in our equation and find c, because we know that tn is equals to an squared plus bn plus c, and then we are told that t40 is equals to 2290, right? We have a, we have b, we have n, so we can find c. So we're gonna have 2290 is equals to a, which is 3 divided by 2, and then n is 40, we square, plus b, right, which is minus 7 divided by 2 multiplied by 14 plus c. So now we can essentially find c. So we're going to have 2290 being equals to 2400 minus 140 plus c. So if you do that arithmetic, you're going to get c is equals to 30. The first 4 terms of an arithmetic sequence are 65, 73, 81, and 89. And then 3.1.1 says determine an expression for the nth term of the sequence we have, right? We know fully well that for an arithmetic sequence, the general expression is given as Tn is equals to a plus n minus 1 multiplied by d. So a is always the first term, right? So at this point, we know that Tn is equals to 65 plus n minus 1 multiplied by d. And then now let's pay our attention to d. D is the common difference, right? You can find d by saying that t2 minus t1, or you can say that t3 minus t2, as long as you finding the difference between 2 consecutive terms, right? Basically we're saying tn minus tn minus 1, right? So let's take t2 minus t1 and see what we get. So t2 is 73, and then t1 is 65, and then if you find the difference of that, you get 8, right? So now we can say tn is equals to 65 plus n minus 1 multiplied by 8. So tn will be equals to 65 plus n multiplied by 8, that is 8n, and then minus 1 multiplied by 8, that is minus 8. So now we have tn is equals to 8n, and then 65 minus 8. 65 minus 8 is 56. 7. So we're going to have plus 57 here, and then we have our general formula. After you find this expression, substitute one term and see if you get the right answer. For instance, put 2 here and see if you're gonna get 73, right? Just like that. So let's go ahead and do that. So T2 will be equals to 8 multiplied by 2 plus 57, right? And then that is 16 plus 57. 16 plus 50 is 66, plus 7, that will be 73. So indeed our formula is working. So now we're convinced and we can move forward. Let's do 3.1.2. 3.1.2 says let's calculate the value of the term in the 1000th position. So we want T 1000. So T 1000 will be equals to 8n plus 57. In place of n, we're going to put 1000. So this will be equals to 8 multiplied by 1000 plus 57. So 8 by 1000 is 8000, right? Plus 57. So we have 8057. And then that's our 1000th term. And then 3.1.3. It says let's calculate the sum of the first 1000 terms. So the sum is given by n divided by 2 multiplied by 2a plus n minus 1 multiplied by d. So we want S1000, right? The sum of the first 1000 terms. So we're going to have 1000 divided by 2 multiplied by 2. 2a. What is a? A is the first term, so that is 65 plus n minus 1, so it's 1000 minus 1 multiplied by the difference, which is 8, right? So multiply by 8, and then if you put that in your calculator, you're gonna get 4,061,000. That seems to be correct. Let's do 3.2. 3.2 says an arithmetic and geometric sequence have the same first term, right? The common difference and the common ratio have the same value. The fifth term of the geometric sequence is 80, and then determine the first 3 terms of the arithmetic sequence. So the first term of the arithmetic and the geometric are the same, right? It's said to be 5, and then the common difference and the common ratio have the same value. So let's do it like this. So the difference is equals to the common ratio on the geometric, right? But they're the same, so let's just put x. Let's use x, right? And then okay, let's have the arithmetic and the geometric. So for the arithmetic, we're gonna have 5 as the first term, right? And then the second term will be 5 plus the common difference. And then the third term will be 5 plus 2x, and then 5 plus 3x, and so on, right? And then for the geometric series, the first term is 5. And then the second term, we know fully well that the formula is AR to the n minus 1, right? So for the second term, we're going to have 5x. And then for the third term, we have 5x squared. We have 5x to the 3. And the fifth term, we have 5x to the 4. And so on, right? And then we are told that the fifth term, 5x to the 4 of the geometric sequence is equals to 8, right? So now we can say that 5x to the 4 is equals to 80. Now we can divide both sides by 5, right? You're going to get x to the power of 4 is equals to 16, right? If we take square roots on both sides, we're going to get x squared is equals to 4. And then if we take square roots again, we get x is equals to 2, or x is equals to minus 2. Now to actually answer our question, which is to determine the first 3 terms of the arithmetic sequence, if x is equals to 2, right? If x is equals to 2, then the first term will be 5, the second term will be 5 plus x, right? here it is here, 5 plus x. So the second term will be 7, and then the third term will be 5 plus 2x, so that will be 9, right? So we can have 5, 7, 9 if x is equals to 2. But then if x is equals to minus 2, then the first term will be 5, the second term will be 5 minus 2, 3, and then 5 minus 2 multiplied by 2, that is 1. When I looked at this question, I was thinking, wow, I'm going to need a lot of creativity to answer this question. But then when I actually tried answering it, I realized that it's so easy, right? I think the mistake most people do with this kind of questions, they look at it, it looks intimidating, and they just leave it. Sometimes, just try the question and see what happens. So here, the question is saying, calculate the value of y if this expression here plus this expression is equals to this expression. And then I realize very quick that this is the sums, right? So I can just calculate S1 being that sum there, and then plus S2 being this sum here, and then I equate it to S3 being that sum there, right? I've not broken any rule in math, so that should work out. And then let me show you what happened. So S1 is the first sum. Let's see what happens when I calculate that. So that will be equals to, we can see that we go in from 1 to 5, right? So you substitute 1 into the equation, substitute 2 until you substitute 5, right? So if I substitute 1, the equation is gonna be, so we have p is equals to 1, right? So 4y remains as it is, and then plus 3p. We know that p is equals to 1, so this will just be plus 3, right? And then now I can add the second term, because for a sum, you add in the terms, right? Assuming the sum is finite. And then now p is equals to 2. We're going to have 4y plus 3 multiplied by 2, because now p is equals to 2, right? So we're going to have 4y plus 6 plus 4y again plus 3 multiplied by, now p is 3, right? 3 multiplied by 3, that is 9. So for the fourth term, we're going to have 4y plus 3 multiplied by 4, which is 12. And then plus 4y plus 3 multiplied by 5, which is 15. So now we are just adding all these terms together, and we have S1. I want you to realize something now. We have 4y, 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 and 4y, right? We have 5 4y's. So the sum of that will be the same as 4y multiplied by 5. And then we have 3 plus 6 plus 9 plus 12 plus 15, right? We group in the like terms, so to say. So 3 plus 6, that is 9, right? And then plus this 9 here, that will be 18. And then 18 plus 12, that will be 30. And then 30 plus 15, that will be 45. So we have 4y multiplied by 5 plus 45. And that will be equals to 4 multiplied by 5, that is 20. So we have 20y plus 45. And we have our first sum. Now we can move ahead and calculate our second sum, right? You should realize now that, yeah, this question is not that difficult. It just looks scary. So the first term, right? We substitute in k is equals to 4 until we get to 7. So we're going to have 3 multiplied by 2 to the power k minus 1. So we have 4 minus 1, and then let's move to the second term. Plus, again, 3 multiplied by 2 to the power, now we have 5 minus 1, right? We're moving up until we get to 7. Plus 3 multiplied by 2 into 6 minus 1, and then plus 3 multiplied by 2 to the power 7 minus 1. Here we don't have any variable, right? So you can just put this entire expression on your calculator and get the answer, right? So the answer here is going to be 360. So now we have S1, S2. Let's find S3. So S3, we're going from j is equals to 1 to j is equals to infinity. So if we go into infinity, we obviously cannot calculate the individual terms, right? Because we'll never really go to infinity. In any case, what is infinity, right? Equation for another day. So here we have the equation being, the equation is 1 divided by 3 to the j minus 1, right? So the first term of the sequence, right? So let's say a. So a here is going to be equals to 1 divided by 3 to the power j minus 1. J is 1, right? So we're going to have 1 minus 1 being equals to 1 divided by 3 to the power 0. Any number to the power 0, we know that is equals to 1, right? So the first term here, a, is equals to 1. And then from there on, what is the common ratio? The common ratio is 1 divided by 3, right? So we have a diverging geometric sequence here. And then to calculate the sum of that, we're going to have a divided by 1 minus r, right? But then what is the value of a? A is equals to 1. So this is going to be 1 divided by 1 minus the common ratio, which is 1 divided by 3. If you put that in your calculator, you should be getting 3 divided by 2. And then now, let's finish our problem. I'm just going to finish the equation here, right? Like we've said, S1 plus S2 should be equals to S3. What is S1? S1 is here, right? 20y plus 45. S2 is here, 360. So we have plus 360. And then S3 is 3 divided by 2. So if we want to find y, we are going to say that 20y is equals to 3 divided by 2 minus 45 minus 360, right? Now we divide both sides by 20. So we're going to get y is equals to this entire term divided by 20, right? Divided by 20. And then here we're also dividing by 20. So y is going to be equals to minus 20.175. So we have a hyperbola g of x given as minus 4 divided by x minus 1 plus 2. And then the first question, 5.1, is saying let's write down the equations of the asymptotes of g. So g of x is equals to minus 4 divided by x minus 1 plus 2. But then, what is the general formula of a hyperbola? The general formula of a hyperbola, f of x is equals to a divided by x plus p plus q. We need the vertical asymptote and the horizontal asymptote. So the vertical asymptote is given by x is equals to minus p, and the horizontal asymptote is given by y is equals to q. So let's look at our equation g of x and determine minus p and q, right? So let's start with q because it's pretty much straightforward, right? We just have plus 2. So the horizontal asymptote will be y is equals to 2. And now let's come to the vertical asymptote. We need x to be equals to something. So let's go to our equation g of x, right? We have x minus 1 here. And we're saying that the equation must be x is equals to minus p. So p in our equation is minus 1. So that tells us that minus p will be positive 1, right? So we have x being equals to 1. So we have our horizontal asymptote, which is y is equals to 2, and our vertical asymptote, which is x is equals to 1. Another way of determining the vertical asymptote, you can just see x minus 1 is equals to 0, so x is equals to 1. 5.2 says, let's determine the intercepts of the graph of g with the axis, right? So we need the intercepts. We have two intercepts, the y-intercept and the x-intercept. Let's start with the y-intercept. So y-intercept, what do we know about y-intercept? We know fully well that for the y-intercept, x is equals to 0, right? So we take our equation g of x and let x be equals to 0, and we solve for y, right? So y will be equals to minus 4 divided by x minus 1. In place of x, we put 0 because we want the y-intercept. So we have 0 minus 1 plus 2. So y will be equals to minus 4 divided by minus 1 plus 2. So that will be equals to minus 4 divided by minus 1, that is just 4, right? Plus 2 is equals to 6. So the y-intercept is the coordinate. For x, we know we need 0, and then for y, we have 6. So that is our y-intercept. Now let's move forward and do the x-intercept. So x-intercept, y is equals to 0, right? So in place of y, we put 0 and we solve for x. So we're going to have 0 is equals to minus 4 divided by x minus 1 plus 2. We just substitute in y is equals to 0 on our equation g of x, right? We have minus 2 is equals to minus 4 divided by x minus 1. You just subtract minus 2 on both sides. If we cross multiply now, we're going to get minus 2x plus 2 is equals to minus 4, right? So we're going to have minus 2x being equals to minus 6. So x is equals to 3. So our point for the y-intercept would be 3 for x and 0 for y. And then we have our x-intercept. Let's move to 5.3. 5.3, it's saying let's sketch the graph of G. Show all intercepts with the axis as well as the asymptotes of the graph. So when you sketch in a parabola, you basically just need the intercepts and the asymptotes. After you get those right, you cannot go wrong. So let's have our x-axis and see what we can do here. So we have our x-axis and then we have our y-axis, right? And then let's start with the equations of the asymptotes. We know that the vertical asymptote, we have x is equals to 1, right? So here at 1, we're supposed to have a vertical asymptote. And then the horizontal asymptote, we have y is equals to 2. So here at 2, we're supposed to have our vertical asymptote. And there we have it. Now let's have our intercepts, right? Our intercepts basically determine where the wings, so to say, of our parabola lies, right? So intercepts, we have x is equals to 3. So here at 3, we have our intercept, right? So one wing must cut here at 3. And then for y, we have y is equals to 6. So here at 6, we must have a wing cutting through. So how can we now construct our graph? We know fully well that part of our graph must cut through 3, right? And then we must not touch the asymptotes. And then the other part should go through 6, but we should not touch our asymptote. So this is how we construct our parabola in this instance. Grade 12 Mathematics, Paper 1, September 2021, right? Past trial examination question on parabolas. We have a 6.1 here saying to us, let's determine the coordinates of C, the turning point of F, right? So let's look at the equation of F first, right? F is given to us as minus x squared plus 4x plus 5. And we want to determine the coordinates of the turning point, right? To determine the coordinates of the turning point, you first find the x value of the turning point. And after you've determined the x value of the turning point, you can then determine the y value of the turning point, right? So the formula you use for the x value of the turning point, you say that x is equals to minus b divided by 2a. When your equation is on the standard format, right? We know that minus 1 will be a, 4 will be b, and then 5 will be c. If we substitute that in our equation, we get minus 4 divided by 2. We see in a is minus 1, so this will be minus 4 divided by minus 2, which is equals to 2. So our x value for the turning point is 2. Now we can substitute 2 in our equation and find the y value of our turning point. So we can say f of 2 will be equals to minus 2 squared plus 4 multiplied by 2 plus 5. So we have minus and then 2 squared, that is 4. Then 4 multiplied by 2, that is 8. And then plus 5, right? And this will be equals to 9. So the coordinates of C, our turning point, is 2 and 9. And then 6.2, let's write down the range of f. So I've sort of conned an idea for the range of f, right? So if f is concave down, then the range will be y is less or equals to y of the turning point. And then if it's concave up, we have y being greater or equals to the y of the turning point. Clearly our parabola is concave down, right? It is ultimately going down. The values of y are ultimately going down. So we have y being less or equals to the y value of the turning point. We know fully well that here in our situation is 9, right? And then when you look at the graph itself, the y values of these graphs can never exceed the 9, right? 9 is the highest point this graph can reach. Now let's do 6.3. So 6.3 says let's calculate the length of AB. So we have A here and we have B here, right? A and B are the x-intercepts of our graph. So let's find those coordinates so that we can determine the length AB, right? So we know fully well that f of x is equals to minus x squared plus 4x plus 5, right? So we know that if you want to find the x-intercept, you equate y to 0. So we're going to have 0 is equals to minus x squared plus 4x plus 5, right? It's a bit tricky to factorize when you have a minus here, so I'm gonna divide everything by minus 1, right? So 0 divided by minus 1, that is 0, and then we have x squared minus 4x minus 5, and then now we can factorize, right? So the question I ask myself again, which two numbers do I multiply? And then I get minus 5. But when I add them, I get minus 4. That is minus 5 and plus 1. So I have minus 5 and plus 1. So x is equals to 5 or x is equals to minus 1. So clearly the x coordinate of A will be minus 1, right? We cannot say the coordinate of B is minus 1 when B is clearly on the positive axis, right? And then the x value of B, that is 5, right? So what is the length from A to B? The length from A to B is 6, right? The length from A to B is 6 units. From minus 1 to 5, it's 6 units. So here we can say AB is equals to 6 units, right? We're basically saying that the x value of B minus the x value of A, which will be 5 minus 1, which is 6 units. And then now let's do 6.4. 6.4 says, let's determine the equation of G. G is a straight line that passes through D and B, right? Clearly. So to find an equation of G, since it's a straight line, we need y is equals to mx plus c. So we need to determine the gradient, and we need to determine c. So how can we possibly determine the gradient? You can see from our sketch that D and B, they lie also on our equation G, right? So if we find the gradient of dB, then we have the gradient of our line G, right? So let's see how we can do that. So we have the gradient of dB being equals to y2 minus y1 divided by x2 minus x1. We have the coordinates of B. We know fully well that is 5 and 0, right? And what about the coordinates of D? It seems like we don't have the coordinates of D, right? But then we can see fully well that D is the y-intercept of our graph F, right? So it should be easy to find. So y-intercept, we let x be equals to 0, right? So f of 0 will be equals to, so what's our equation? So we substitute in 0 here, that will be 0, and then we substitute 0 here, that will be 0. We'll only be left with 5, right? So f of 0 is 5. So now we can say that the coordinates of D is 0 and 5. So now we can, go back to our equation and find the gradient. So let's take D as our second point. So y2 will be 5 minus y1, which is 0, right? And then x2 will be 0, the x value of D, minus the x value of B, which is 5. So we have 5 divided by minus 5, which is equals to minus 1. So now we know fully well that the gradient here is minus 1. But what about the value of C? C is the y-intercept of G, right? The y-intercept of G is the y-intercept of F. And we know that that value is 5, right? So the equation of G will be y is equals to minus x, right? Minus 1x is just the same as minus x, right? Plus the y value of the intercept of G, which is 5. So we just have minus x plus 5. But then you can also substitute D into the equation or B into the equation. You will still gonna get 5, right? And then now let's move to 6.5. 6.5 is saying T is a point on F such that D and T, T is a point on F such that D and T are reflections of each other over CVN. Write down the coordinates of T. So let me, erase a few stuff for the sake of clarity. So we have our point D, right? Yes, our point D. Let's make it clear. And then T is a point on F such that D and T are reflections over CVN. So T should be somewhere here, since it is a point on F, but it's a reflection about CVN, right? So yeah, let's just draw a straight line. If T is a reflection of D about CVN, then D and T should share the same y value. So now at this point we know that the y value of T is the y value of D, which is 5. Now we only need the x value. If it's a reflection over CVN, then the distance between D and CVN should be the same as the distance between CVN and our point T. So what is the distance between D and CVN? We know the x value of D is 0, right? and then we can find the distance here by using the x value of our turning point. The x value of our turning point is 2, right? So from D to CVN is 2 units. Then from CVN to T, it will also be 2 units, right? So if we add 2 from 2, we get 4. Now the coordinates of T, the reflection of D over CVN will be 4 and 5, right? And that's how you essentially determine it. And then 6.6 says the line EC is the tangent to F at C. The line EC, okay, there it is. And then write down the gradient of this tangent. This line EC, it touches the turning point, right? We know fully well from definition that the gradient at the turning point is equals to 0, right? So the gradient of that line EC will be M is equals to 0, right? It's flat. You can, just see it when you look at it. And then let's determine the coordinates of E. So 6.6.2, we want the coordinates of E. So E is here, right? E is where G and the tangent intersect, right? So let's find the equation of that line EC. The equation of that line EC will be y is equals to mx plus c. We know fully well that the gradient is 0, so this part here falls apart. And just left with y is equals to c. But we know the value of c, right? The y-intercept is right here, is the y-coordinate of the turning point. Our turning point is C, right? So the y-coordinate of our turning point, we determined it in 6.1. We know that it is equals to 9, right? So at E, g of x is equals to 9, essentially, right? It's equals to the equation of EC. So now we can say that 9 is equals to the equation of g of x. We determine it somewhere, minus x plus 5. So we have minus x plus 5. So minus x will be equals to 4. So x is equals to minus 4. So that is the x value of E, right? But then we know the y value of E is supposed to be equals to 9, because that's the equation of line EC. So now we can say that the coordinates of E is minus 4 and 9, right? If you use the equation of g of x, you should still get minus 4 and 9 also. And then let's move to 6.7. 6.7 says let's determine the value of k for which y is equals to minus x plus k is a tangent to f. So y is equals to minus x plus k is a tangent to f. If y is equals to minus x plus k is indeed a tangent, then at some point f of x should be equals to y, right? Because if it's a tangent, then they touch at some point. If we determine the y value where they touch, right, and the x value where they touch, then we can determine the value of k, right? So let's start with the x value where they touch. So this is how we can, potentially determine the x values where they touch. We can equate their gradients, right? So we can say that f prime of x is equals to y prime. So if we derivate f of x, we get minus 2x plus 4 is equals to minus 1. We're using the power rule, right? We're derivating f of x and y. So now we can say that minus 2x is equals to minus 5. So x is equals to 5 divided by 2. So at this coordinate 5 divided by 2, this is where the two graphs touch, right? Now let's find the corresponding value. So you take this x value and you substitute it in the original equation, right? So f of 5 divided by 2 will be equals to minus 5 divided by 2 squared plus 4 multiplied by 5 divided by 2 plus 5, right? So if you put that in your calculator, you're gonna get 35 divided by 4. So now we can come back to this equation here and determine our k. So we can say that 35 divided by 4 is equals to minus x plus k. But then we know the x value at that point, right? We're saying that it is 5 divided by 2 plus k, right? So we're gonna have 35 divided by 4 plus 5 divided by 2 being equals to k. So our k is equals to 45 divided by 4. So what do we have here? September 2021 trial examination, grade 12 mathematics. We have a log function here, and it has an equation h of x, which is equals to the log of x base a. And then 7.1 says let's calculate the value of a, right? So these kind of questions are very repetitive. Like all the time when a log function comes, they ask almost the same exact questions. Is it that you will find a log function or you will find an exponential function? They are always almost the same all the time. You're gonna have to find the value of a, which is part of the equation, and then the way you do that, you take a point on the graph and you substitute it, and then it becomes easy to find a. So there's a logarithmic rule that we're going to use in this question. Let me show you the rule I'm talking about. So we saying that log of a base b, if this is equals to c, then a is equals to b to the power of c. This is the rule we are going to be using. So let's do 7.1. So 7.1, we're going to substitute the point on the graph like we're saying, right? So let's substitute point p. Point p, the x value is a half and the y value is minus 1. And then don't forget we have our equation here, h of x, right? So if we substitute that point in place of y or h of x, we have minus 1, and then that will be equals to log of in place of x we have a half, and then the base is a, right? Now it becomes extremely easy to see that after you substitute point p, you can find a with ease. So how do we find a? We are going to use this log rule, so to say, that we're talking about. So now we can say that a to the minus 1 will be equals to 1 divided by 2, right? So how can we determine a? If we write 1 divided by 2 in such a way that it has an exponent of minus 1, then we can drop the exponents and equate the bases, right? So we're gonna have a to the minus 1 being equals to 2 to the minus 1. 2 to the minus 1 is the same as 1 divided by 2. So now you can see that the exponents are the same, so we can drop them and equate the bases. So we're saying that a is equals to 2. So our equation h of x will now become log of x base 2. So now when you have this 2 here, you can try substitute the x value of p and see if you get minus 1 for the y value of p. And then if you get minus 1, then you know indeed what you did is correct. And then if you don't get minus 1, there is a mistake you made. Let's move forward and do 7.2. So 7.2 is saying let's write down the equation of h inverse in the form y is equals to. So how do you find the inverse of a function? Well, the first step, you'll swap x and y, right? So you swap x and y, and then the second step, you solve for y. And after you've done that, you are essentially done, right? So let's see what we're talking about. So we know that h of x or y is equals to log of x base 2. So let's go ahead and do step number 1, which is to swap x and y, right? So in place of y, we're gonna put x, then this will be equals to log of, in place of x, we put y, and then base 2. So now we solve for y, and after we have solved for y, we have essentially found the inverse of our function. So let's do step number 2. So for step number 2, we're using this rule again that I showed you up there. So we're going to say that 2 to the power of x is equals to y. So let's just write it nicely, right? Y is equals to 2 to the power of x. So y is equals to 2 to the power of x is the inverse of our function h of x, right? You just swap x and y, and then after you swap x and y, you solve for y. And let's do 7.3. 7.3 saying write down the domain of the inverse of h. The inverse of h is clearly y is equals to 2x, right? The domain of a function is all the x values of which the function is defined, right? Clearly y is equals to 2x is defined everywhere, right? If the numbers are extremely large, getting closer to infinity, the function is defined. If x is 0, the function is defined. And even for all negative numbers, the function is still defined. Now we can say that x is an element of a real number, right? Any real number, y is defined, the inverse of h of x. Or you can write it in this notation, right? So we're coming from minus infinity all the way to infinity. Our function h inverse would be defined. But what about this function? Let's say g of x is equals to 1 divided by x. What about this function? What's the domain of this function? Clearly, you should see that at 0, this function is not defined because we cannot divide by 0, right? So when the question says, let's find the domain, you just don't write minus infinity to infinity. It depends on the function. You have to analyze it first. And then 7.4 is saying, determine the values of x for which h of x is less or equals to minus 1. So when you have a log function or you have an exponential function, you basically substitute the equation of that function and solve it algebraically, right? Versus if you are dealing with a trig function. A trig function is more complicated. That's where you have to analyze the graph. But then here is safe to substitute the equation. So let's go ahead and do that. So we know that h of x is said to be less or equals to minus 1. So in place of h of x, let's substitute log of x base 2 being less or equals to minus 1. Again, this question we're going to apply this rule, right? And then if we do that, we get x is less or equals to 2 to the minus 1, right? 2 to the minus 1, we already say that that is 1 divided by 2. So x is less or equals to 1 divided by 2. So we need x to be 1 divided by 2 or less, right? But then that's not all. Let's look at our graph in the sketch here. I want you to realize something. Log is not defined for 0 going down, right? So the value of x always has to be slightly above 0 so that log can be defined, right? So here we're just gonna add that the value of x needs to be slightly above 0. Let's see if we can find the derivative of f of x is equals to x squared plus 5x minus 6 using first principle. So which formula do we use when we want to find the derivative of a function using first principle? We say that f prime of x is equals to the limit as h turns into 0 of f of x plus h minus f of x divided by h. What is left now is substituting on this part of the equation, right? We just write in f of x but then everywhere where there's x, we put x plus h, as you can see in this equation, and then we minus by f of x itself, and then we divide everything by h. But then what's going to happen at some point of time, we're going to take h as a common factor in the numerator, and that h in the numerator will cancel out with the h in the denominator. If that doesn't happen, then we have done something wrong. So let's go ahead and see what happens. So we have f prime of x being equals to the limit as h turns into 0, and then now let's write f of x plus h. So we have x squared. In place of x squared, we're gonna put x plus h squared, right? And then plus 5x. In place of x, we put in x plus h, and then minus 6, right? And then we subtract the function itself, right? So we're gonna have x squared plus 5x minus 6, and we dividing everything by h, and this will be equals to the limit as h turns into 0. So now we're solving this here, x plus h squared. So we say that x multiplied by x, that will be x squared, and then x multiplied by h multiplied by 2, that will be plus 2xh, and then h multiplied by h, that is just h squared. And then now we have plus 5 multiplied by x plus h, right? We're gonna get plus 5x plus 5h minus 6. And then now we can take the function out of the bracket, right? We have a minus there, so we have minus multiplied by x squared, so that will be minus x squared. And then we have minus multiplied by 5x, that will be minus 5x. And then we have minus multiplied by minus 6, so that will be plus 6. And then let's divide everything by h. What's going to happen now? Every term that doesn't have h is supposed to fall apart at this step, right? If you can see here, we have x squared, right? And then here we have minus x squared, so that will give us 0. And then we have plus 5x, and then we have minus 5x, that will give us 0. We have minus 6, we have plus 6, that gives us 0. So what we're left with here is just 2xh plus h squared, what else, plus 5h, right? And then let's write that down. So the limit as h turns into 0 will be 2xh plus h squared plus 5h divided by h. Now we can take h as a common factor in the numerator. If we do that, we get the limit as h turns into 0 being equals to h, and then we'll be left with 2x plus h plus 5, and then we divide everything by h. So now h and h is going to cancel out, right? And then let's let h turn into 0. If we let h turn into 0, then f prime x is going to be equals to 2x plus 0 plus 5. This is just equals to 2x plus 5, right? If you want to prove whether this is true or not, you use the power rule, right? If we use the power rule on x squared plus 5x minus 6, we're going to get 2 multiplied by x to the 2 minus 1 plus 5 multiplied by 1 to the x minus 1 minus 1, right? And then 6 is a constant, so it's just going to fall apart. So we end up with 2x plus 5. And then that should tell you that what you did is correct. And now let's do 9.2. So 9.2 here, let's determine f prime of x if f of x is equals to 3x multiplied by the square root of x minus 4. I don't know about you, but it's very hard to multiply with the square root, right? It's better if we just write it as to the power 1 over 2. So f of x, we can write it as 3x multiplied by x to the power half minus 4, right? So now we can further simplify. If we further simplify, we're gonna get 3x, right? We know that there's always a 1 here, right? So that will be 1 plus 1, so that will be 1.5, which you can write just 3 divided by 2 minus 3 multiplied by 4, that is 12, so we have 12x, right? So now we can then use the power rule to solve this. What is the power rule again? Just to remind you, if we have some function kx to the n, right? Then if you derivate that, you should get k multiplied by n multiplied by x to the n minus 1, right? K being the coefficient of our x, right? So let's use the power rule there and see what happens. So we have f prime of x being equals to, so we're going to have 3 multiplied by 3 divided by 2 multiplied by x to the power 3 divided by 2 minus 1. And then let's apply the same to 12x. We're going to have minus 12 multiplied by 1 and then multiplied by x to the 1 minus 1, right? So this will be equals to, so we have 3 multiplied by 3 divided by 2, 3 multiplied by 3, that is 9. If we divide it by 2, we just get 9 divided by 2, right? And then now we have x, so we have 3 to the power 3 divided by 2 minus 1, right? So that will be a half, and then minus, so we have x to the power 1 minus 1. Any number to the power 0 is 1, right? So we're just going to get minus 12, and that looks like we have solved our problem. Let's do 9.2.2. So 9.2.2, see, let's find dy dx if y is equals to x cubed minus 4x divided by 2 minus x. This one is a bit complicated, right? But let's see what we can do. Let's take x as a common factor on the numerator, right? So we're going to get y is equals to x, and then we're left with x squared minus 4 divided by 2 minus x. And wait a minute, now we have a difference of 2 squares, right? So we can factorize that. So we're gonna have y is equals to x, and then now we have x minus 2 multiplied by x plus 2, right? And then we're dividing everything by 2 minus x. But then our denominator here, 2 minus x, if we take minus as a common factor, right, we're gonna have y is equals to x multiplied by x minus 2 multiplied by x plus 2, everything divided by minus. We're taking minus as a common factor, right? So we should get plus x, right? Plus x minus 2. So now you should be able to see that x minus 2 and then x minus 2, they cancel out. So now we're going to be left with y is equals to x multiplied by x, that will be x squared, right? This and this here. And then there we're going to have plus 2x, right? And then we're dividing by minus 1. So y should be equals to minus x squared minus 2x, right? And then now we can use the power rule. If we use the power rule, we're going to get y is equals to minus 2x to the 2 minus 1 minus 2x. So we're multiplying by 1 here for the sake of clarity. Let me just write it down, right? And then 1 minus 1. So here we're gonna get minus 2x, and then any number to the power 0 is 1. So we just have minus 2x minus 2. So in this question, we're given a cubic function, right? F of x, which is equals to x cubed plus bx squared plus cx plus d. And the first question, 10.1, is saying let's write down the value of d. Before we even look at our sketch, let's look at our equation and see what D means, right? So here's D here. I just circled it in red. I want you to realize something here, that if you say f of 0, right, you're going to get 0 cubed plus b of 0 squared plus c multiplied by 0 plus d. So f of 0 is going to be 0 cubed, that's 0, plus b multiplied by 0 squared, that is 0, plus c multiplied by 0, that is 0, right, plus d. So f of 0 is basically equals to d. And we know fully well that if we say x of 0, we're looking for the y-intercept, right? So d is the y value of the y-intercept. So let's go to our graph and see what the y value of the y-intercept is. You can see here that c is the y-intercept, right? And then the y value there is 4. So now we can conclude that d is equals to 4. And now we can do 10.2. 10.2 is saying, let's show that b is equals to -3 and c is equals to 0, right? So the rule of thumb in math is that if you have two variables, you're going to need two equations. If you have three variables, you're going to need three equations. So since we have two here, let's try and find two equations. So what we can do, we can substitute this point A on our graph f of x, right? So we can say sub A into f of x, right? So if we sub a into f of x, in place of f of x or y, we're going to get 0 is equals to, and then in place of x cubed, we're going to have -1 cubed plus b multiplied by -1 squared plus c multiplied by -1 plus d. But we know that d is equals to 4, right? So let's solve this. 0 will be equals to -1 cubed, that will be -1, and then -1 squared, that will be 1. So we have plus b, and then minus c plus 4, right? So we're gonna have 0 is equals to 3 plus b minus c. So let's make b the subject of the formula, right? So that we don't have to divide both sides by -1 if we make minus c the subject of the formula. So we're gonna get -3 plus c is equals to b, right? And then from here we cannot do anything else, so we can name this equation 1. And now we can find another way to find another equation, and then we'll solve simultaneously. So we only have coordinates for point A and C, right? We've used point A. Now let's use point C. But wait a minute, in 10.1 we used point C, right, to find the coordinate of D. So we can no longer use point C as it is. We have to find another way of manipulating point C, right? But then point C is the y-intercept and the turning point at the same time, right? And we know fully well that the gradient at the turning point is equals to 0. So what we can say now is that f prime of x is equals to 0, right? So now we're just going to derivate x, right? Let's not forget x is x cubed plus bx squared plus cx and so on, right? I just circled it in red here. So if we derivate that, x cubed, we're gonna get 3x squared. We just apply in the power rule, right? And then plus 2bx plus cx. If we derivate cx, we're just going to get c, right? And then d, we know that it's 4. It's a constant, so if we derivate that, we get 0, and that will all be equals to 0. The gradient at the turning point is 0, right? But we know the value of x at the turning point, right? It is 0 because c is the y-intercept, right? So we're gonna have 3, and then for the value of x, we have 0 squared plus 2 plus 2b, and then 0 plus c is equals to 0. So you'll see that this here falls apart, right? And then this here falls apart. So now we are only left with c is equals to 0, right? And then this can be our equation 2. Now let's sub equation 2 into equation 1, right? So we're gonna get -3 plus, we know that c is 0, is equals to b. So minus 3 is equals to b. And that's exactly what we are asked to prove, right? So yeah, there we go. We just solved the problem. Now let's do 10.3. 10.3 is saying let's determine the equation of the tangent to f at x is equals to 5. So back to the basics. What do we know about a tangent? We know that the equation of a tangent is that of a straight line. Y is equals to mx plus c. If you want to find the equation of a straight line, you're going to need the two things. You're going to need the gradient and the coordinates of one point so that you can determine c, right? So to find the gradient, we're gonna use f prime x, right? We're going to derive f of x and substitute the x value to find the gradient. But then now we have the gradient sorted. How are we going to find the value of c, right? We need a point to find the value of c. We know that we are interested at the point when x is equals to 5, right? So if we substitute 5 into f of x, then we're going to be able to find the y value of that point. So let's, go ahead and do what we're proposing. So f prime x, we have already derivated, right? But then we can do it again. We know that now our equation f of x will be equals to x cubed, right? And then we know that b is minus 3. So we have minus 3x squared, and then c is 0. So this part here falls apart, and then plus d, of which is 4, right? So if we derivate this, we're going to get f prime of x is equals to 3x squared minus 6x, and then plus 4 falls apart with derivating, right? So now we have the equation for the gradient. If we substitute 5, we're gonna get the gradient itself, right? So f prime of 5 is equals to 3 multiplied by 5 squared minus 6 multiplied by 5. So 5 squared, that's 25, multiplied by 3, that is 75. And then 6 by 5, that is 30. And then this should give you 45, right? So the gradient is 45. This is the gradient m, right? So now we have the gradient. Let's find the y value of the point. We know that x is equals to 5 at that point, right? So what we can do here, we can say f of 5 is equals to, now we're substituting into the equation itself, right? 5 cubed minus 3, 5 squared plus 4, right? And then if you put this in your calculator, you should get 54, right? So now we have the point and we have the gradient, right? The gradient, we're saying that it is equals to 45. And then now the point, when x is equals to 5, right? We have 5 and 54 as the corresponding y value. So now we can go ahead and try find the equation of our tangent, right? So we're gonna say y is equals to mx plus c. M is 45, right? X plus c. So let's sub this point 5 and 54. If we do that, we're gonna get 54 is equals to 45 multiplied by 5 plus c. So 54 minus 45 multiplied by 5 should be equals to c. And then if you put that in your calculator, I kid you not, you're gonna get minus 171 is equals to c. So now we can say that y is equals to 45x plus c. C is minus 171. And yippee, we have the equation of our tangent. Yeah, such an exciting problem. Let's do 10.4. Let's do 10.4. 10.4 is those kind of problems that, people don't really want to do, but yeah, it's not that bad. So they're saying, for which values of k will f of x equals to k have 2 unequal positive roots and 1 negative root simultaneously. Okay, so let's look at our equation. In this instance, we have 1 negative root, right? And then 1 positive root. Basically, when we're speaking about a root, we're just speaking about the x-intercept, right? We have 1 negative root and 1 positive root, right? But then how can we shift our graph such that we can get 2 unequal positive and 1 negative root, right? So let me show you what you can do. So if you shift your graph slightly down, then let me just finish doing that. If you shift your graph slightly down, then here we're going to have 2 positive roots, and then here we are still going to have our negative root, right? So if we just shift our graph slightly down, right, then we are good to go. But then if you shift your graph too much, then problem arises. Let me show you what I'm talking about. If you shift your graph to such an extent that it's at this level, then we're going to have 1 neutral root, because that root will be at 0, right? And then we're also going to have 1 positive, and that's not what we're looking for. So we are shifting our graph down, but then we should have a limit of how much we shift it down, because if we shift it too low, then issues are going to arise, right? So we have fx is equals to k, right? And then at the roots, the equation should be equals to 0, right? So what we can do here, we can say f of x minus k is equals to 0. So minus k is what is shifting our graph. K is shifting our graph at certain units up or down, right? So let me show you something. Let's say, for instance, k is minus 1, right? If k is minus 1, then we're going to have f of x minus 1, right, is equals to 0. So we're going to have f of x plus 1 is equals to 0. And then you will realize that if we have f of x plus 1, then we are actually moving our graph up, right? And then we don't want that. We want to move our graph down. So that tells us that k has to be greater than 0 in order for us to move our graph down, right? So now what we can say is that let's make sure that k is greater than 0, because if k is less than 0, we are going to have a minus multiplied by a minus, which is going to give us a positive, and we'll actually be moving our graph up, and that's not what we want. So let's make sure that k is greater than 0, right? But then, like I said, we need a limit. We cannot just move the graph infinity units down, right? This situation that we were talking about here, when we have a neutral root, right, and 1 positive root, this occurs when k is equals to 4, right? When we move our graph 4 units down. And then another thing you should realize is that if we move our graph 5 units down, then our graph just keeps on going down, right? And then we don't have what we're looking for. So we need k to be between 0 and 4, right? If k is between 0 and 4, then our graph will have 2 unequal positive roots and 1 negative root simultaneously, and that's what we're looking for. Now we can do 10.5. If this is not so clear, I've done a problem that had something like this. So maybe you want to, visit the channel and look for a cubic function playlist. Let's do 10.5. 10.5 is saying determine the coordinates of the local minimum of g if g of x is equals to f of minus x plus 3. Let me just make our sketch more appealing. So the local minimum if g of x is equals to f of minus x plus 3. So you can see that g of x is the transformation of f of x, right? So let's find the local minimum of f of x and do the transformation, and then we're gonna find the coordinates of the local minimum of g. The local maximum of f of x is here at C, and the local minimum is here at B, right? So if we find the coordinates of B, then we can apply the transformation like I'm saying, and then find the coordinates of the local minimum of G. So let's go ahead and find the coordinates of B, right? How do we find the coordinates of B? B is the turning point, so the gradient there is 0, right? So we can say f prime x is equals to 3x squared minus 6x is equals to 0, right? That's what happens at the local maximum and minimum. So now we can take x as a factor, right? So we're going to have x, and then 3x minus 6 is equals to 0. So x is equals to 0, or x is equals to 2, right? you can see here at C that's where we have x is equals to 0, right? So at B, that's where we're going to have x is equals to 2. So the coordinates of B will be 2 and 0 because it is the x-intercept, right? So the corresponding y value is 0. So let's apply the transformation. G of x is equals to f of minus x. So instead of x, for g of x, we have minus x, right? So if we make the transformation to coordinate B, we're gonna get minus 2 and 0. And then apart from that, we have this plus 3 here. And like we were saying on 10.4, that 3 moves the graph up or down, right? So here the y value was 0, and then we move in 3 units up, right? So instead of B being minus 2 and 0, we're gonna get B being minus 2 and 3. We are given information here about a cubic function f of x. Here's the information here, right? And then they're saying let's use this information to draw the graph, right? Let's indicate all the intercepts with the axis as well as the coordinates of the turning points. So step number 1, when you're doing a question like this, is to determine where all your points lie, right? After you put all your points on the graph, you determine the turning points. After you get the turning points, you're essentially done because you know the general shape of the graph. So let's, go ahead and do that. So we know that when f is 0, right? When f is 0, y is 3, right? So we can put 0 here, and then we know that y is 3 when f is 0. So we're supposed to have a point here. And then when x is minus 3, y is equals to 0, right? So when x is minus 3, y is 0. So we have a point here. Let's indicate it by a cross, right? And then which other point do we have? Let's keep this for now because there we have gradients, right? F prime x. Let's focus on the points. When x is minus 2, y is 5. So here when we have minus 2, y is 5. So we have a point somewhere here, right? And then when x is 1, y is 1. So here let's have 1 for x and 1 for y. So we need another point here, right? And then now we can focus on f prime x. F prime x is the gradients, right? Every time when the gradients are equals to 0, then we know that that is the turning point. So when x is equals to minus 2, we have a turning point, right? But we know that when x is equals to minus 2, the y value is 5. So this point here, which I'm circling, is the turning point. And at 1, we have another turning point. The gradient is 0, right? But we know that when x is equals to 1, y is equals to 1. So here at this point, we have another turning point. So now you can sort of, see how your graph is going to look like. So we have this turning point here. So we're supposed to turn. And then when we come to this point, we're supposed to turn again because it's a turning point, right? And then it keeps going up. And then on this side, it keeps on going down. Now we just have to indicate our coordinates, right? So here we're saying that this is 1 and 1. And here we're saying that this is minus 2 and 5. And here we have 0 and 3. Here at this point, we have minus 3 and 0. And yeah, that's how we construct our graph. You start with the points, you determine the turning points, and now it becomes easy to see what your graph is supposed to look like. And then 11.2.1, it says, let's use the graph to answer the questions below. Determine the values of x for which x multiplied by f of x is less than 0. So x, what is x? X is the value of the x coordinate, right? And then f of x is the value of y. We need values of x for which the product of the two is less than 0. So one has to be positive, and then the other one is negative, or the other one is negative and the other one is positive, so that the product can be less than 0, right? Essentially negative. So let's look at our graph. In the positive x-axis, both x and y are positive, right? So there is no way that can be part of our solution, right? But then let's look at the negative axis. Here between -3 and 0, x is negative but y is positive, right? So the product of the two will be less than 0. But then if you go below -3, then both y and x are negative, so the product will be greater than 0. So we only need the x to be between -3 and 0. If x is between -3 and 0, then x multiplied by f of x will be less than 0. And then 11.2.2 says if g of x is equals to minus f of x, write down the coordinates of the local minimum of point G. The coordinates of the local minimum of point G will be -2 and -5. Why am I saying that? Watch this video in the screen right now. So this is another question on the past trial examination, September 2021, grade 12 mathematics. So we have the word pandemic. So let me just write down the word. We have the word pandemic. And then 12.1 is saying that how many unique arrangements of the letters can be made, right? How many unique arrangements of the letters can be made? So let's look at our word. We have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 different letters. And how can we arrange these 8 different letters? So let me create spaces. So we have 1, 2, 3, 4, 5, 6, 7, 8. So in the first position, there's 8 possible letters you can put in the first position when you're arranging the letters. So we have 8 possible ways in the first position. And then in the second position, because you've already placed one letter, you have 7 positions, 7 letters that can fill that position. So we have 7. And then on this third position, you have 6 letters that you can put in that position. You can see the trend now. So here you're going to have 5, 4, 3, 2, 1. So basically you have 8 factorial ways which you can arrange these 8 different letters. And then 12.2 says determine the number of unique arrangements of the letters that are possible if each arrangement must start with the letter P and end with the letter C. So fine. Let's have 1, 2, 3, 4, 5, 6, 7, 8. Right? On the first letter, they're saying that let's start with P. It's a must. And then on the last letter, let's have C. It's a must. How many ways can you arrange the letters in this word if the first letter is P and the last letter is C? So here on the first position, we only have one possible letter, which is P, right? So we have 1. And then on the second position, there are 6 possible letters because of the 8, one letter is in position 1 and then one letter is in the last position. So this second position, we have 6 possible letters that we can place there. And then on the second position, we have 5 possible letters because we have exhausted 3. And then on the fourth position, 4, 3, 2, 1, right? So we have 1 multiplied by 6, 5, 4, 3, 2, 1. So that's basically 6 factorial. And then the last letter is C. We only have 1 C. So that will be 1. So 12.2, we have 1 multiplied by 6 factorial multiplied by 1. Right? This one is because the first letter has to be P and we only have 1 P. And then this one, the last letter has to be C and we only have 1 C. And then the letters in the middle, we have 6 letters remaining and 6 positions. So we can arrange them in 6 factorial ways. And then 12.3. Calculate the probability that randomly chosen unique arrangements of the letters will start with the letter P and end with the letter C. So the probability of an event A is equals to the number of possible ways event A can occur divided by the sample space. What is the number of possible ways that the arrangement of letters can start with P and end with C? That is the answer to 12.2, right? 1 multiplied by 6 factorial multiplied by 1. But then what are the possible arrangements of the letters if we don't have any restriction? If we don't have any restrictions, we have 8 factorial ways we can arrange the letters. So we basically have 6 factorial divided by 8 factorial, and that is equals to 1 divided by 56. Each passenger on ABC Airways flight chose exactly one beverage from tea, coffee, or fruit juice. The results are shown in the table below. We have male, female, we have tea, coffee, fruit juice, and then the totals. 13.1 says write down the value of A. We can see here that 60 is the total number of males, and then 100 is the total number of females, and then A is the total number of males and females. So we say in 60 plus 100, which is equals to 160. Or you can add these columns going down. You're going to have 60 plus 80 plus 120, which is also equals to 160. And then 13.2 says determine the probability that a randomly selected passenger is male. We know fully well that the probability of event A is equals to the number of ways A can occur divided by the sample space, right? The sample space being the total, so to say. So we want the probability of selecting a passenger that is male. So how many males do we have? We've already established here that we have 60 males, right? Is the total number of males. So we're going to have 60 divided by the total number of passengers in the flight, right? So we have 60, which is the males, plus 100, which is the females. So the probability of picking a person in random and that person being a male will then be equals to 3 divided by 8, which you can convert to decimals and even a percentage. 13.3 says given that the event of a passenger choosing coffee is independent of being a male, calculate the value of B. So keyword independent, right? So if we have independent, then we have situations where the two are dependent. So let's address independent first. So if the events are independent, then the probability of A and B will be equals to the probability of A multiplied by the probability of B. But then if the events are dependent, and the probability of A and B will be given by the probability of A multiplied by the probability of B given A, right? Given that A occurs. So here we have an independent event, so we're going to stick to this. But then if we had a dependent in a different situation, then you do what we say in here. So let's go to our table and look at B, right? B is the probability of a male choosing coffee. So probability of being a male and choosing coffee, it will be equals to the probability of being a male multiplied by the probability of choosing coffee, right? From our formula here for independent events. So we have B divided by the sample space, which is 160, being equals to the probability of being a male, we already said that that is 60 divided by 160, right? So we have 60 divided by 160 multiplied by the probability of choosing coffee. So let's look at the total number of people that picked coffee, right? So we have coffee here, and then we just go on a straight line, and here's the total. So 80 people picked coffee. So we're gonna have 80 divided by 160. So we're basically solving for B. So we're gonna have B being equals to 60 divided by 160 multiplied by 80 divided by 160 multiplied by 160. We're multiplying by 160 on both sides so that we can find B. Yeah, so basically we're gonna have B is equals to 30.